already. Coming back to chapter 8, going to pick up where we left off. One of the things we were doing was this circle class, and we had one field, it was radius, it had a double, it was private, just rehashing, going through a whole UML chart. We added a method called equals, where I brought in an object as a parameter, and I returned a Boolean to see if they were true or not. The only things I had to check on this simple example was, did the radius of the parameter coming in from the argument in the call have the same radius as the calling method? Okay. Any questions on what we had covered, including 8.4 with the toString method? All right. Again, y'all need to be doing the asking when I say, are there any questions? So we took care of 8.4. We took care of toString. We took care of 8.5, which was the equals method. And again, we did a call of an object dot equals and passed in the parameter of another object. All right, so moving along, we're going to hit section starting with, we did the equals method, correct? We did 8.5. So today we're going to start with 8.6. Now, other things that you're going to need to be able to do as you move along the course is, what if I want to copy one method to another? Well, the way I would copy it is, I couldn't just do a simple assignment where R1 gets the value of R2, because we know we're dealing with reference variables, and we would have this reference address. So what we would have to do instead is write a method called copy. And inside of that method is where we would actually have to copy variable to variable, like an int to an int, if that was a field, or a double to a double, if that was a field. Or if I had arrays, now I go into something called deep copy, where I'd have to copy all the individual elements of the array from R1 so that I can get it and store it in R2. You notice R1 is calling. So that means inside that copy, I would have to create a new object so that I could return it and store it. So one way to copy objects is to create a method called the copy method. Okay. Another way to take care of this is by creating a constructor, and the constructor, when I call it to instantiate a new object, would pass an object in as an argument to my, again, my rectangle. So if I look back on my UML chart and I wanted to be adding things, I would want to now add, let's see, the copy constructor is going to be, the copy method is going to be public. What am I bringing in? Well, let's see, if I go back and relook at this again, nothing being passed in, but the calling object has values available. But inside of this copy, what I'm going to have to do is create a new object, in this case called circle, that would be my return type, so that I could then store it in this fellow. Finally, another way to copy would be a constructor. And what would I have in the constructor? Not a default constructor, not a constructor with the radius coming in, but this time I'd have a constructor with what coming in? What would be the parameter list here?
A circle.
A circle, right? I'd have to actually pass in a circle object. So I'm really starting to slowly build more and more things that I could put in that eventually are going to pay off. So if I ever want to do any copying, I can do a copy method or a copy constructor. Questions? Okay, moving along in chapter 8, we get to the next section, and it has something called aggregation. Aggregation is kind of cool. It's just as we keep learning more and more things, we're combining them to things that we've already done. And what aggregation is, and I think you have a program eventually, you're going to have to do some aggregation, is when an instance of a class, that means you have a class, like R1, an object of a class, but it's the field of another class. All right, so I gave you in D2L an example of some files I'd like you to load up. So if you can jump to D2L and go load up under the news item, the files course demo, instructor, and textbook. And the first one we're going to take a look at is, in fact, instructor. Give you a little more time to load that up. As you're loading it, instructor is a class. It's information about an instructor. It's a class that once it's set up, anybody can use it in a program, right? We would just instantiate an object of type instructor. Instructor has fields, last name, first name, office number. I have, let's see, this is instructor. So I see right away, I have a constructor that brings in last name, first name, and office. I also have a second constructor. This instructor, it brings in another instructor object. This is that copy instructor we were just talking about. Copy constructor. And as you see, here's the object coming in, and I'm going to copy all the values over to the new one that's calling it. We okay with that? The other thing inside of instructor, I have a set that sets all three. We called that a mutator. And I have a nice string function, or toString, to get ready to start to prepare things to print out. And again, the book has the UML chart, which if I gave that to you, you would be able to blow that up and make your code. Next one is another class. This is a second class called textbook. You jump over and take a look at that. And, so I'm starting to put together things for college that, the instructor could be one class. Sure. Textbook information could be a different class. Title, author, publisher. There's things like ISBN numbers and so on. But first constructor, bring in the three fields. Second constructor, if you're looking at it, nice and simple. This is another copy constructor. I'm bringing in a textbook object, and I'm taking, this is that deep copying again. Title to title, author to author, publisher to publisher. And textbook also has a toString. Now, aggregation is going to come into play when I take a look at course. So if I load up course, I have the name of the course, which is good. But then I also have an object for the instructor and an object for the textbook that are fields in my class. So I have a class, I'm used to ints and strings and doubles in here, maybe even bizarreness of an array. But now I just have another data type that I include inside of here. Nice. I have a constructor, brings in information, Yeah, yeah, buddy. Brings in the name. It brings in an object for the instructor, an object for the textbook. Again, this is aggregation. When I have objects that are fields, I come in here, I set the name, I use the copy constructor to send all of the instructor information over, and I'm going to use the copy constructor to send all the textbook information over. So the copy constructor we're seeing now is not a bad thing to have. Some other things inside of course, I have get name, I have get instructor. You notice how I am calling the constructor for instructor so that I can return an instructor. Huh? Should I say that again? We good? Down here, get textbook. It's all in one line. Instead of saying create a new object, take the current textbook, pass it in, send it over to instantiate an object. Once that object is created, I then return it. So if I wanted to get the textbook information. Finally, down here in my toString, do you notice that I'm calling instructor, which now is going to call the toString from the instructor class. And I'm going to call textbook, which now calls the toString from the textbook class. This is one of those, the first time you look at it, you're going, bam, like a fish running into a wall. Once you got it, it's like, oh, I got it. That was kind of a piece of cake. So it's really sort of like an all or one. But this class is using objects from the other two class. This class is using the constructors from the other class. This class is using the toStrings from the other classes. And this is a big stepping stone for what's coming up shortly with us as far as substrings, or excuse me, subclasses and superclasses. And of course, hopefully you ran the demo. You were able to get it to run. And as you can see, we have the course UML chart, and we do a little diamond. This indicates aggregation and how all this is laid out. And when you get ready to do the program for this, I strongly recommend you have some sort of layout like this before you start. Some sort of pseudocode set up in this manner to help keep you organized. Otherwise, you could possibly be all over the place. This is where I think everybody needs to have whiteboards in their house like Sheldon, so they can go and put their notes up and look up and see them whenever they want. That was funny, but that's okay. Some issues. One of the issues that we may have is when I have fields like instructor and textbook that are actually different objects, that when I create them, I don't do that address assignment, that I'm actually calling the constructor, to do the copy constructor so that it can go deep, goes deep inside and copies the individual pieces instead of just the addresses. And if you're not really sure what I'm saying, you can read more about it with this performing deep copying versus shallow copying. A simplified example of that is if I have an array, I don't just copy the name because that copies the address. I have to go and copy all of the individual elements. That's where the deep copying comes into play. Aggregation. Questions? I know, I need to get you folks typing something because you'll start to fade on me. So again, I have notes here. Shallow copying is when you make a copy of an object, right? It's only the reference. Deep copying is going in and copying all the individual values from each of the fields over. Okay, section 8.8. This goes back to the old days, and I'm going to show you with two examples. But we have something called the this for referencing the this variable. It's kind of hard to say. In the old days, we used to have to do this. We don't anymore. And what I mean by in the old days is when I get ready and I instantiate an object called stock, and I have constructors coming in, SYM and price, symbol and price, that I could copy them over. Well, in the old days, we used to have to do for all of the local or the objects field, we used to have to put the word this in front of it. So we knew that it was the calling object symbol. Well, that is sort of faded out and it's gone away, and we don't see it that much anymore. But if you wanted to use it, and the example is given is, what if I can't be creative enough to come up with names in my parameter list that are different than my fields? So up here I had fields in my object called symbol and share price. Well, what if I wanted to put those in my parameter list? Well, I could actually get away with it. And the way I would do it is say this symbol is going to be assigned to the calling object symbol, but I'm going to put the variable name this in front of it to make sure that it goes to the fields of the calling object. Same with share price. They're the same names. I put this in front of it so it knows it goes to the right one. This guy is here and this guy is there. They're the arguments coming in. They're like local variables that get created. But in order for us to assign it to what we want it to be, we put the this variable in front of it. This is so much fun. I know, right? Okay, the last section of chapter 8 that we're going to take a look at, and then I'm going to have you go back and do a little coding, is something called an enumerated type. Now, we can create another data type. This time I'm creating a data type called day. You know, we have our data types, int, we have arrays, we have strings. I'm creating one, it's called an enumerated data type called day. Inside of day, I want to give it the values: Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. Now, all this is doing is naming the number location in my set. So the number 0 is now can be represented by Sunday. Sunday does not have double quotes. It's just Sunday. Okay, sort of like true and false. True and false can almost be considered an enumerated data type. It would be false, comma, true. Okay. Sunday is 0, Monday is 1, Tuesday is 2, and it goes all the way through. So some people like to be able to code with names instead of numbers. I don't know who they are, but every textbook still has the enumerated data type in it. Okay? This is something called an ordinal data type, which means everything has a successor and a predecessor. If I looked at Tuesday and said, what comes after Tuesday? You would tell me Wednesday. What's the predecessor of Tuesday? Monday comes before it. So there's an example of enumerated data type. And I go back to D2L and load up car type, car color, sports car demo. You can even throw sports car demo 2 in there as well. All right, the first one I have listed is car type. You notice I'm creating an enumerated data type, I'm saving it in a file all by itself. Car type, Porsche, Ferrari, and Jaguar, 0, 1, and 2. All right. I have car color, red, black, blue, and silver. I have something called sports car. And I'm going to take a look at sports car. Before I do, I want to jump into this Enum demo 818. I don't think I gave that to you, and I probably should have. In Enum demo, I declare just what I was talking about a few moments ago. Okay. In here, I create a variable name called workday of type day, and I'm giving it the value Wednesday. So workday can have any one of these. Right now, workday has the value of Wednesday. I can print it out, and when I print it out, it's going to print out the word Wednesday. I can come in here and say the ordinal value for that is, and the ordinal value again would print out a 0. Again, nobody uses enumerated data types that I know of. Anyhow, I'm covering it. We can do an ordinal value for Saturday. Its value is 6. We can even come in and do comparisons. Day Friday dot compared to day Monday. We've seen this compared to once or twice, not too often. So it actually is doing a greater than or less than if I wanted to. Remember, it's returning back to the numerical value of the order when it was declared. So is Friday greater than Monday? Well, Friday was associated with the number 0, 1, 2, 3, 4, 5. Monday was a 1. 5 is greater than 1. So I'm able to compare those back and forth. Okay. So anyhow, we're looking at car type. And I have a little bit of that aggregation kind of thing going on again, where I have make is from car type, color is from car color, using those two classes. Price is just a double. And hopefully you ran through this and you saw a nice example of when you ran the demo, what kind of car you want. Hopefully the car you want made that list. Yeah. Somebody just say yeah, because I haven't heard anybody talk in like 10 minutes. Yeah. Okay. So I have options for what we're going to do next, but I think what I'm going to do is come back to our circle class. And, we're down to 15 minutes, so we don't have a ton of time to do a big program. But I would like you within your groups, or why don't you just do this by yourself? Go back to your circle class. I'd like you to add another constructor that has circle as an object. I'd like you to add a copy constructor. And then over in your demo, test both of those to make sure they work.